Hey, what's going on everyone? This is Brian with FNS Ball Pythons, a beginning ball python breeding channel. And I tried to dress up a little bit today to maybe appear a little smarter than I actually am, so we'll see if it works. But you know, as I've been starting this journey, a lot of my family and friends are starting to learn about genetics, and they're asking me questions. They're actually going on YouTube and looking at all your videos trying to find the answers. And they said, you know, a lot of the videos were a little confusing, over their head, you know, really long. So they said, you know, hey, you should make one that like we could all understand. So I'm gonna give that a shot. So basically the main three things are dominant, codominant, and recessive genes. And I'm just gonna kind of dumb this down how I understand it and how I try to explain it without a lot of the science mumbo jumbo that I don't even understand completely. So we have dominant genes. You know, for one, it's like we could think of a leopard right here. So if you basically take a dominant gene animal and you, let's say, pair it to a normal, some of your babies are going to carry that dominant leopard gene, and that's that. Now there's percentages, but we're not even going to worry about that today. And one of the things with dominant is you take that leopard and you pair it to another leopard, you're only going to get the possibility of leopards. There's no alteration. There's no, you know, greater value. You can't put the two of them together to create like something super, which brings me into codominant or incomplete dominance. In ball pythons, people just call them codominant. So codominant is something like pastel, right? So you take this pastel and you put it to a normal. It's the same thing as the regular dominant gene. You're gonna get some pastels, some normals. But if you take that pastel and you put it to another pastel, you can get what's called a super pastel. So the codominant genes basically allow you to take two of the same genes and kind of put them together to create a super form. And there's other things that can happen that's a little bit more complicated, where if you take, you know, one codominant gene and another codominant gene and you get like a white snake, there's stuff like that, but that maybe is another video. So for now, when we think of dominant, there's no super form. You're either gonna, if you pair the same dominant gene with the same dominant gene, you get the same dominant gene. Codominant, you take a codominant gene and a codominant same gene, put them together, you could get something totally different, a super form. I mean, that's pretty much that in a nutshell. And then you have recessives. So that's a lot what I'm working with. I'm building my building blocks are for clowns. So they're kind of similar to codominant. So now you have this normal looking snake right here, but it has one copy of the clown gene. So with recessives, in order for you to see what happens because of that gene, you need two copies in that snake. So basically, if you have this normal snake with one copy of the gene, you can't see it. And if you pair it to just a normal snake with no copies of the clown gene, all you're gonna get are normal looking snakes. So basically, it doesn't matter if mommy and daddy have one or two genes, only one gene between the two of them, you won't produce that visual snake. But if mommy, let's say, is a normal with one recessive gene, clown gene, and then daddy is a normal with one recessive clown gene, then the possibility is to get a clown. Now there's, again, with percentages, but don't worry about that today. Now the thing is, if you have a mommy snake, let's say, and it's a visual clown, that means they have two copies of the clown gene. And if you pair it to a normal snake with no copies of the clown gene, you will not produce a recessive visual trait, because even though there's two genes in between mommy and daddy, the mother can only pass down one at a time. So to create recessive animals, all you have to know is mom and dad both have to carry at least one copy of the gene. Now, if you have a visual clown mommy and a visual clown daddy, now they're both automatically going to pass one copy of that gene down, and you guarantee yourself a visual clown. And that gets into percentages, and but again, we're not focusing on all that, just trying to understand those three kind of concepts. So the one other thing is like allelic. You hear that a lot, and basically it's like, I'll take for example the spot nose gene, okay, and the chocolate. So allelic genes aren't in themselves, I guess, allelic. It's the combination of two, right? So if you have, let's say, a spot nose chocolate snake here, and you pair that to a normal here, you can only get either spot nose, chocolate, or normals. You cannot, the allelic genes in that snake, meaning spot nose and chocolate together are allelic. They can never pass down those two genes into one snake. Don't know why, don't know how. There's other videos for that, but that's kind of how it works. The best thing to do is when you find genes that you like, just start studying those. Because there's like 200 plus genes. You're not going to memorize them all. But if you just say, hey, I like that gene, and you really delve into it, find out what it can do, things that you want to make, things that you might have to avoid, how to reproduce them, then you start building your mental library. So, that's pretty much it in a nutshell. Comment down below all the mistakes I made, because I'm sure I did. I'm still learning. I'm trying to make this simple for others out there that are just getting into this as well. I'll look over the comments and maybe do a follow-up video down the road. But thanks for checking in. Please like, share, subscribe, and I will see you next week.